We're going to talk about character set and character encoding. All right, the Ascii character set is the Latin letters, A, B, C, D, all the way through lowercase z. Now they start at, each one has a code that goes with it. They start at number 1 and go to 127. The first 32 are non-displayable characters. For example, the tab and the new line. If we start at 33 and then we go to 127 and print all of these characters, so we use the CHR function to turn this number, 33 ranging to 127, into a character, you can see the resulting character codes. 33 is an exclamation point. Okay, we don't get to any letters of the alphabet till we get to, well, here's the numbers. 48 is 0. 57 is 9. Okay, we don't get to any letters of the alphabet till we get to 65. So the ASCII code for the letter A is 65. And we keep going through the capital letters, the bracket, the slash. Then we have the lowercase letters. 97 is A. Go all the way to 122. Then we have the curly brace, the pipe, curly brace, and then the tilde. All right, so the opposite of printing a character's code, the character from the code, is to use the ordinal function. So, okay, I know that the numeric ASCII value of A is 65. So I run this, it shows that. The ordinal value, or the code that represents A, is 65. Now we have special characters too. For example, the tab and the new line. See, the tab is a /T. The new line is /N. All right, or it can be /R. Sometimes on Windows you have to use /R. Even sometimes on Unix you use /R. So look, when I print this, it's going to indent the word indent me. It will put a blank line before here, put a blank line, and a blank line after, because this code, the slash here, means escape it. So it means instead of printing it in, print the value /n, the number. So when we run this, see, indent me has a tab in front of it. Then we have a blank line, here, put a blank line after me. Now, the tab, notice I escape the escape character twice. That means print the slash versus printing the tab. And then it shows here the ASCII code for /T is a 9. Now, we want to print, okay, the ordinal, okay, Unicode, write it like this, is expansion on the character set. I mean, the letters A to Z only work for English, right? So if we want to do Greek, even German, Swedish, Arabic, we need something larger than that. So Unicode is basically all possible letters, including emojis. But then UTF-8 is a subset of that. Your iPhone, your Android device, your laptop probably uses the UTF-8 character set. Now look here, for example. Okay, this /U means to print the Unicode value of, of 03BB. We run this, it's the lambda in Greek. Okay, that's not UTF, that's Unicode. And then The Unicode value of that is, the UTF-8 value of that, which is what computers are using, is hex, 2 hex characters. It's CEBB. This slash here, okay, the B first of all means it's binary versus something you can display. Binary means it's something that needs to be decoded. This slash 8x means it's hex. This is a 1 byte. This is a 1 byte. Okay? Now let's go back and decode it again. There it is. There's our lambda. Okay? What about the emoji? Here's an emoji. That's a letter too. Turns out this is a 4 byte. 1, 2, 3, 4 byte character. It takes 4 whole bytes to hold this. You know, the letter A just takes 1 byte. All right? Now, if we decode that again, it should give us the emoji. So we're going to take this string here, binary string of 1, 2, 3, 4 bytes, decode it to the UTF character set, print it out. There it is. It's our emoji. All right, now we're going to do something significantly harder. Okay, we want to print the Greek alphabet. All right, so the Greek alphabet, you can look this up in a chart. Lots of charts that give you the code corresponding to different alphabets. All right, I want to start here. Okay, the Greek alphabet runs from the code 52,881 to 53,134. Now, there's a big gap in the middle. The gap in the middle is these letters. Meaning, I don't know why there's a gap, but whoever designed the letters decided to have this gap in the middle. So this gap, you know, is non-displayable characters. You can't decode them. All right, so the Greek alphabet runs from CE91 to CF81. Okay, let's make a range. You know, what we're going to do here is we're going to start at the beginning. All right, here, 52,881. We're going to convert that using the 2 bytes function. Convert this integer, which is FR, to 2 bytes because this is a 2 byte character set versus the emoji, which is 4 byte character set. So we convert that and we print it out. There. We now have converted, you know, what we started off with, turned it into an integer, turned it back into bytes. Now, what we want to do next is turn it into Greek. We do that using decode. Decode. That is the Greek letter alpha. Now what we do here is, okay, we're going to make this loop to print that entire range, except we want to skip over the ones in the middle, the ones that are not valid letters. So in order to do that, instead of hard coding some range, we're just going to put this, try, except. This is how you handle errors in Python. Now, we need to have some statement, something, so we can just put true equals true, because we're saying, try all this stuff. If you can't decode the letter, then you're going to get a Unicode decode error. So then just do this, which is a nothing statement. Say true equals true. All right, we run this. Boom. There's the Greek alphabet, the displayable part. Alpha, beta, gamma, delta, which they say thelda in Greek, not delta. All the way to Omicron. Well, you could do the same thing with the Turkish alphabet if you want, or any other alphabet. Now look at this. The last thing here is I want to show you why you would need this. Okay, so I've made a Unicode file on the internet, put it out there in UTF-16 format. So I open it. I could open a file directly from the internet using URL open function. So I've opened this file here. So look at this. If I say for XNL, print X. Whoa, look. It's a bunch of gibberish. It's because it's encoded. See? Each line is a binary string like this, ending with the /n. So as an exercise, and I'll put the link to this tutorial and the instructions for the exercise. Write a program to decode this UTF-16 and print it out in regular readable characters. Okay. Thank you.